Hello, I'm Hank Green and I want to teach you chemistry. But please, do not run away screaming. If you give me 5 minutes to try to convince you that chemistry is not torture, but instead the amazing and beautiful science of stuff, and if you give it a chance, it will not only blow your mind, but also give you a deeper understanding of your world. This is just my opinion here, but I think that understanding the world leads to a greater ability to enjoy the world, and there's nothing that helps you understand the world better than chemistry. Chemistry holds the secrets to how life first formed, how cancers are cured, how iPhones have bigger hard drives than 5-year-old laptops, and how life on this planet might just be able to continue thriving even hours if we play our cards right. Chemistry is the science of how 3 tiny particles, the proton, the neutron, and the electron, came together in trillions of combinations to form, get this, everything. Now, chemistry is a peculiar science, sometimes talked about as a bridge between the ultra-abstract world of particle physics and the more visible sciences like biology. But calling chemistry a bridge is like calling Eurasia an island. Chemistry has it all. Mad scientists, world-changing revelations, the practical, the impractical, medicine, bombs, food, beauty, destruction, life, and death. Answers to questions you never knew you had. I love chemistry, and I hope I can give you a glimpse into why. So today, let's start out with maybe the biggest idea of all time and move on from there. Stuff is made from atoms. I know. You aren't shocked, you aren't awed, you might not even be paying attention anymore, but when atomic theory was first proposed, it sounded pretty crazy. And yes, we call it atomic theory, using the scientific definition of theory, which is a well-tested set of ideas that explains many disparate observations, not the colloquial definition of theory, which is a guess. Though luckily there's no one running around anymore saying, atoms are just a theory. But it wasn't that long ago that people were running around saying that, and you wanna know who settled it for good? Einstein. Atoms had been postulated for a long time by the 20th century, but it wasn't until Einstein mathematically proved the existence of atoms and molecules in 1905 that the matter was truly settled. And you thought Einstein was all about relativity and E equals mc squared. He also proved atoms exist. Here's how it happened. In 1827, a botanist named Robert Brown was looking at pollen grains in water through a microscope, and he noticed that they jiggled randomly even when there was no movement to cause the jiggling. It was a mystery for a long time, until 1905, when Einstein theorized that this phenomenon was caused by as yet unproven atomic particles actually smacking into the grains of pollen. He wrote up some fancy math, showing that his theory predicted this motion almost perfectly, and everyone had to concede that yes, tiny, discrete bits of matter were indeed smacking into the pollen, and thus molecules, and by extension atoms, must exist. Today, we remember this botanist and his discovery by calling the motion he observed Brownian motion. It's kind of crazy that every physical thing you've ever interacted with is made up of little ball thingies. It started with people wondering what would happen if you just kept slicing something in half forever. Eventually, and of course it turns out that there's no knife sharp enough to do this, you end up with one pure unbreakable bit of that substance. The word atom, indeed, is from the Greek for indivisible, though, of course, as we learned in World War II, atoms can be broken as well. So all the stuff that we think of as stuff is made of atoms, tiny, discrete particles that have specific properties depending on the arrangement of 3 simple subatomic particles. There's the proton, heavy and positively charged, the neutron, about the same size as the proton but neutral, and the electron, which has the same amount of charge as the proton, just opposite, and very nearly has no mass at all, about 1,800 times less massive than the proton or neutron. Protons and neutrons hang out in the nucleus, and thus are the nuclear components, or nucleons. Electrons hang out around the nucleus and are the parts of the atom that do all the interesting chemical stuff. But before we get to the chemistry of the electrons, we first have got to understand the properties of the nucleus. Okay, this is pretty important, so pay attention here. The number of protons in an atom determines what element it is. 79 protons, always gold. 59 protons, always praseodymium. The number of protons in an element is its atomic number. It sits right on top of the box in the periodic table because that is the element's defining trait. So an atom of silver with 47 protons in its nucleus is always an atom of silver. Depending on what its electrons are doing and what it's bonded to, it might be part of a chemical that's silver-colored or black or blue or shiny or poisonous or a cure for disease. But whatever it is, that atom is still silver, and will remain an atom of silver probably forever, because that core number is very, very difficult to change.